We will now determine the formal charge of our molecules. The formal charge will help us determine the efficiency of the electron distribution in the molecule. We'll start out with CCl4. We'll first figure out the charge for carbon. Carbon, as we know, has 4 valence electrons. We will then subtract half the number of bonding pairs, which in this case would be 8, subtracted by the number of lone pairs, which is 0. This will give us a charge of 0 for our carbon. We'll now repeat this process for chlorine. We know that we have 7 electrons, 7 valence electrons. We'll subtract this by 1/2 of our bonding pairs, which is 2 in this case, and then subtract it by our lone pairs, which is 6. This will also give us 0. This means that our formal charge of our CCl4 atom is equal to 0. We will now look at the formal charge of ozone, which, as we know, is a resonance structure. Now, we know that oxygen has 6 valence electrons. We keep track of our oxygens, put little numbers by them. So we know it's oxygen 1, oxygen 2, and oxygen 3. Now, we subtract this by the number of bond pairs, 1/2 times the number of our bond pairs, which of course 1, 2, 3, 4, 5, 6. And subtracted by the number of lone pairs, which is 2. Which will give us a charge, do this, 3, of 1. We'll then look at our second oxygen. 6 valence electrons, subtracted by 1/2 of our bond pair, which is 2. Subtracted by the number of lone pair, which is 6. This will give us a charge of -1. Looking at our third, obviously 6 valence electrons, we have 2 bonding pairs, so 1/2 times 4 is 1, 2, 3, 4 electrons, subtracted by our lone pairs, which is also 4, which will give us 0. So this has a charge of 0, +1, -1, which when we add these together, 0, -1, +1, gives us an overall charge of 0. We will now look at the formal charge of our carbon dioxide atom. Once again, carbon has 4 valence electrons. We'll subtract this by 1/2 of the number of bonding electrons, which in this case, 1, 2, 3, 4, 5, 6, 7, 8. Subtracted by the number of lone pairs, which in this case is 0, which gives us overall charge of carbon, 0. We'll then figure out the formal charge of our oxygen. We know oxygen has 6 valence electrons. Subtract this by 1/2 of our bonding pairs, which in this case, 1, 2, 3, 4. And then subtracted by the number of lone pairs, 1, 2, 3, 4, which will also give us 0. So now we know that the formal charge of our carbon dioxide molecule is 0.